Welcome back to our math class. In this video, we are going to discuss different forms of quadratic function. We said in the previous lesson before, we have different ways to represent a function. We can use graph a function, we can also create a table for the function, we can also write down the equation for the function. So today, in this lesson, we are going to discuss what are the major ways to represent a quadratic function, and for each type of the way to show this, what are the information we can get from that certain form. Let's get started. So quadratic function can majorly written in the three different ways. We can write them in the standard form. We can also write them in the vertex form. We can also write in the intercept form. The reason we call them different ways because from each form we can read different information from the equation. So what we are going to do in this video, we are going to discuss each form and see what are the information we can get from that form. First, we are going to check the standard form. As you can see, standard form is very like universal. We write down, use function notation, and we have three coefficients in front of each part. A is a coefficient in front of x squared, B is coefficient in front of x, C is just a constant term, which is just a regular number at the end. So this is a standard form. So next we are going to look at some examples to see what are the things we can read from A and B and C. So let's look at these two equations. They are all written as standard form. As you can see from x squared to x and then constant term. And let's write down all the information for A, B, C. So for this one, remember A, as we mentioned before, let's write down ax squared plus bx plus c in the front, right, to compare. So we know A is a coefficient of x squared and B is coefficient in front of x. Do not forget the negative sign. And C is just constant to 1. The reason we review this because next when we talk about the quadratic formula, then you will use this number to help us to figure out the information. Also, one more thing I want to remind you, the A value is always 1, tell us how the graph open upward or downward. When A is greater than 0, meaning when A is positive, we always have open upward, which means we have the minimum value of y. However, when A is less than 0, then the graph will open downward, then we are actually looking at the maximum value of y. This is the information we can use. Next example, we have two terms here from x squared 7x. So we know A is number in front of x squared. When we see no number, meaning there is an invisible 1. And B is -7. So for C, since we have no constant term here, is actually considered as 0. Again, we can use this to help us to figure out how do we use quadratic formula. Also, one more thing I want to remind you, since A is positive, we can predict the graph will look like this, and we're looking at the minimum value of y. Okay, so that's for the standard form. For the vertex form, as you can see, we have quite different way to write it. We have the coefficient in front of the parentheses, and we have this number right in here. What does that mean? So the reason we call vertex, because once the function is written in this form, I can easily read the vertex from the graph, which in this case is hk is the vertex. Okay, so hk is a vertex. And also, as we mentioned, when it's greater than 0, it's open up. We're looking at the minimum value. And when it's less than 0, it's going down. So we're looking at the maximum value. And these two values here can tell us what is axis symmetry and this one tells us minimum or maximum value of y. So let's check two examples to help us to understand this. Let's check the first one. The first one, as you can see, this is written as x minus 2 squared plus a. Since there's no number in front of this, it's considered invisible 1, so a is 1, which is greater than 0. And we know it's going to look like this. So we're looking at the minimum value. As we mentioned, we can read the vertex here. So it's going to be, so the value of 2 here is -2, so it's going to be 2 and 8. So this is a vertex, and according to the previous lesson, we talked about the graph, so we know axis of symmetry, which is a vertical line, passing through the vertex look like this. So we know it's going to be x equal 2. And also we know the minimum value of y, which is matching to the y-coordinate of the vertex, which it means the minimum value of the graph is actually 8. So this is how we read this information. Next, as you can see, a is in number in front of this part, so a is less than 0. We actually predict this graph is going to look like this. So we are looking at the maximum value for this. And how do we read the vertex? Pay attention here, because when we read, originally the graph is actually look like x minus h plus k. So if this is when you plus a number, you just need to read the opposite value here, which is -3. Consider the number, the value, make this part as 0, which is the opposite value of the term constant here, like a number here, so it's -3. Then we just read the outside number, which is -5. This is our vertex. So we always read the opposite part of this vertex, and we know that the axis symmetry is always one passing through the vertex, so we know axis of symmetry for this case is x equal -3, and we are looking at the maximum value of y, so which is -5. As you can see, we can read a lot of information from the vertex form. That's why vertex form is very commonly used in quadratic function. Lastly, intercept form. Probably you can predict here. Intercept form, we still take the constant in front of this and we factor the whole equation into the two parts multiplying each other. And the reason we call this intercept form because the two values here, P and Q, is actually matching to the two intercepts, x-intercepts and x-intercepts. So these two values will be presented here. So P and Q are x-intercepts. So that's why we call intercept form. Let's check the example to have a better understanding for that. So for this one, as you can see, the A is invisible, not really invisible, but there's an invisible 1 here, so A is -1. That means this graph is open downward. So we know the x is, we are looking at the maximum value. We cannot read this information directly from this, but we clearly know the two value of x-intercept, which is x equal 3, and the other one is x equal -5. Remember, you always read the opposite value, which is make this part as 0. So x minus 3 is 0, 3 minus 3. So that's why one of this is 3, and the other one is -5. Because this x-intercept always made y, oh sorry, it should be on the left side, always made y as 0. So that's why I read the opposite value of this. So x-intercepts, we can know is this, or we can also show zeros of function are the ones of this, right? So for this one, as you can see, A is a number in front of this, this is 3, so which is a greater than 0 positive number, so we're looking at this. So actually matching to the minimum value. We know that. But what are the two values of the x-intercept? How do we read it? As you can see, the first part, we have the other number next to this. So we can consider is x minus 0. The other one is x minus 9. We just read the opposite value, which is one is 0, the other is 9. So that means x-intercepts, we already know that, which is you can see 0, 0 or 9, 0, but if we read it carefully, zeros of function is going to be, oh, sorry for that. So for the zero of function is actually x equals 0 and x equals 9. This is all the information we can read from intercept form. So as you can see, intercept form and vertex form, we can read a lot of very useful information from the graph. So that's why, compared to standard form, we prefer to use vertex form or intercept form because they are very useful to to display a lot of information from the graph without us to graph the function. Okay, so I hope this video is helpful for you to understand all the different forms of the quadratic function. Thank you so much for watching. See you soon, everyone.